Gosh, it seems like 1,000 sprints ago. I fought my way out of that fog. Started to use Clear TH. Realized I loved it. I know I said no more bugs, but I was really hoping to pull off that one last one.
The software has changed. None of us can go back. All we can do is our best. And sometimes the best that we can do is to start over.
I see all these tests fail.
I keep telling everybody they should move on. Some do, but not us.
Even if there is a small chance, we owe this to everyone who's not in this room to try.
We will. Whatever it takes. Whatever it takes.
Whatever it takes.
Whatever it takes.
I like this one.
Hello, everyone. I hope you can hear us here as well. And I welcome you to our special edition of Exactpro's AI Testing Talks webinars. My name is Anna Maria Lukina. I work at Exactpro. The video that you've seen is from 2019, our historical archived video that we produced many years ago. I'm very happy to show it back again. I'm very glad to see new subscribers and attendees to our webinars today. Welcome. So for those who has joined us for the first time at these webinars, we have launched those with one purpose: knowledge sharing across the industry. And we usually invite speakers from various companies and fields, share their opinions and expertise on various topics around software testing and AI. And I just trying to check whether we have slides on sharing. Let's see. I would like to introduce our special guest.
Yes.
He, of course, does not need any introduction, but for the proud of members of the Underrock community, I would tell. Michael Bolton is the most influential and recognizable voices in modern software testing. Michael Bolton's greatest hits, let's call it this way, in software, but just in software testing, the rapid software testing methodology itself, the widely discussed article, Testers Get Out of the Quality Assurance Business, that we are going to mention today. Most recently, Michael co-authored the book with James Buck, Taking Testing Seriously, which brings together greatest experience and decades of thinking about testing as an investigative, human-centered discipline. Michael has been mentoring professionals among 35 countries throughout all these years, and influences many practitioners with his work. Thank you, Michael, for giving us that opportunity and joining us today. Hi.
Thanks for having me.
Yeah. Do you have anything to add to what I mentioned and what we have on the screen?
Well, you said I need no introduction, so I
Right.
guess I don't.
Agreed. Yes. So we have. I once also wanted to introduce our host. Yosif Vitkin is with us today. Hi, Yosif. He is Exactpro CEO and co-founder. And we need to go to another slide.
Whoop, whoop, oh, too far.
Yes.
Well, go back one.
Yosif is broadcasting the slides, and
There
he's
we
not
go. He
willing
just
to
wants to
share
get
the
to the
experience that
meat.
he has. Yes. Hi, Yosif. Are you there?
Oh no, he's muted.
Yes, yes,
Oh no.
I
There
am
he is.
Oh,
here.
perfect.
It
Yes,
is
great.
a dream comes true. I'm having my second live stream today with RST co-founders. The first was accident when James decided to like live stream his experiment into YouTube, but this one is deliberate. So thank you very much, Michael, for joining us.
You're welcome.
Yeah, thank you very much. Let's start. So this session is going to be a bit different comparing to what we've had before on our test or webinar AI tests, AI talks webinars. So we are going to have a couple of questions with the slides or without the slides. We are waiting for the audience that are listening to us on LinkedIn to ask questions via LinkedIn chat. We're going to through the LinkedIn chat. Once we have anything, we will stop with the slides, and between discussion, we'll address some of your questions. So please do not hesitate to leave a comment or just say anything to us. So we'll try to address if there are any questions. And here you see on the screen the article that I mentioned before, Testers Get Out of the Quality Assurance Business. And this article, in our opinion, remains one of the most influential and thought-provoking ever written about software testing. So many of the ideas raised there are still highly relevant to us today. And I wanted everyone who is listening right now to respond to the questions that we have here. This article, which best describes your perspective on this article. So one of the options that we have on the right-hand side, please leave us a response. So you could respond that you've never heard about the article, you heard about it, but you never explored it, familiar about the critique about of the QA term, familiar with it or mostly agree, familiar with it and mostly disagree, and do not think it is important. Just leave us a message and we'll see how many of us thinking likewise or how many of us disagree. Hello, hello. While you're responding, let me tell anything else about the article. What is particularly striking with this is that this article has been issued 16 years ago, and the industry still continues struggling between the distinguishing what is software testing and what is quality assurance. And that misunderstanding of the actual roles and purposes is still present nowadays. That's very interesting. That's for so many years we have not made clear distinction about that. This I'm checking the answers. Please leave us.
We
Yeah,
have survival bias in this
Where
chat.
would I see
yes.
that now? I'm
The
intrigued.
responses.
Yeah,
So you
I'm
can
looking at a Zoom
access.
screen right now.
Yes, you can't see it here. We are checking the chat of the live stream on
Okay.
LinkedIn event. So you can access the LinkedIn event and you'll see that people are sharing their opinions in the chat. Thank you very much, everyone who is doing that. So
I'm worried
currently,
I'm worried if I go to the LinkedIn event that we'll get a lot of crosstalk and echo and that sort of stuff. So
yes, don't do that. Don't do that. But
okay.
it's all will stay there, and we will be able to see the results anyway after the recording. So I see many D's,
Mostly
many
D.
mostly D's,
We
like
do
people
have
are familiar
various
with.
bias. Yes, we have couple
Yes.
of B's. We have one F, and we have one C. No one, everyone is too shy to say E.
Yeah.
Yeah.
And no one left A, by the way. So majority have heard about the article. Some of them explored. Most of them agree, and one person doesn't think that it's important. Michael, what do you think about the answers?
Of course, everybody's welcome and encouraged to have their own answers. But what I am interested in, though, a lot of the time, when people disagree, I want to hear what the nature of the disagreement is and why. What their sort of evidence is for the argument that I'm making. Now, of course, their response might be an emotional one, right? It's I don't care. Well, it's okay not to care in certain kinds of circumstances if you're willing to recognize the consequences of not caring. You know, I believe that it matters. What we call something is important, I think. For example, you've got there the idea rose is a rose is a rose, but I think it was, I remember something from Jerry Weinberg's work in which he said, well, how would we feel about a rose if we called it a stink plant? You know, would it convey the same kind of feeling? Would it introduce a bias to the way we think about it? And the labels that we use for things are important, I believe, especially in the sense that these days there are lots of great big machines that are being trained on strings of symbols. Machine learning models, large language models, are being trained on strings of symbols, and those machines don't have social competence. They don't have a sense of things in the world. They don't know what things are like in the world. That's exactly why yesterday I was amused when I looked up, I was trying to find a blurb for a conference talk that I'm going to be giving fairly soon. I couldn't find it locally. So I decided I'd go to Google and look up best in test. And sure enough, here's a description created by the AI overview of Michael Bolton, a tester in 35 countries, and all that sort of stuff that's not actually that important, but the RST methodology and so on. And then below that, there's an image of Michael Bolton, the singer, but Michael Bolton's greatest hits or Michael Bolton's best or something like that. So people and algorithms can get messed up by the labels that we use for things. And there's lots of ways, for example, in which we dehumanize people when we render them to a label, right? They're positive and negative ways of naming people or groups of people or classes of people. And a lot of that language makes a difference in our perception of it. Our words and our ideas are tied together.
Do you think there are any cases where it is a good idea to have an ambiguous term that can be specifically misinterpreted? Especially in our field of work in software testing.
Well, let's think about the term clickbait. You can use all kinds of language in all kinds of ways. One of the ways you can use it is to be provocative, to try to shake people's ideas up a little bit. Or you can use it to be descriptive, or you can use language to be normative, or you can use language to make a joke. That's okay. All those things are fine. Um, but it's what's going on behind the words. What's going on behind what are the ideas that we're representing with words? What are the intentions that we have? Those are the important things to me. So it's
Yusuf, do you have anything to add?
No, I think most of objections that I saw is that it is not an important distinction, and then in the very same post, it will mean the same thing and two different things. But
well,
Mm-hmm.
once again, if you disagree, argue back. That this is a really important thing. It's not to one of the reasons we're as happy with our book as we are is because
Yeah.
it represents years of experience, but about 4 years of arguing about what's in it because we wanted to get it right. We wanted to represent exactly what we thought as best as we can with text, and that's how the craft progresses when we argue about stuff.
Yeah,
Uh,
that's what I wanted to say. When we argue about stuff, we will bring the truth, basically, in
Right,
the
right. I
end.
mean, that's why in court there are arguments. That's why in parliamentary systems, in democratic systems, people argue, and that's not necessarily fun all the time for everybody concerned. Um, a, a, I remember the first time I went to the Netherlands, and I learned a little bit about the polder model, which is the Dutch term for describing how decisions in the Netherlands sometimes take forever because they're interminable arguments about it, debates and discussions and public meetings and analyses, and it all goes back and forth. But ultimately, that kind of process leads to at least a thoroughly considered decision, if not necessarily a speedy one, and not necessarily an uncontroversial one, even after it's decided. But that's how things progress. That's how humans have progressed all the time.
Yeah, having said about the critiques, we have one of the examples that are currently on the screen. They are it is about the book Software Testing Strategy by Matthew and Michael, and the argument they were disagreeing with RST was around the word assurance. So they were referring to another definition of the word assurance. They stated that assurance is a statement that something will certainly be true or will happen, especially when there has previously been doubt about it. And I wanted to raise this subject with you, Michael. What do you think about it? So as I understand that, let's have an example. My husband is going back home, and he assured me that he's coming back at 5:30, maximum at 6 p.m. And I accepted that as a promise, as assurance that he's coming back at that particular time, but he does not have any. There are different parameters that can make him stay longer at work. He will be delayed there, or he will stay longer in an unusual traffic jam or anything else. So many things that might be impacting on him, but he's still been assuring me that he is coming back home at that particular moment. So I understand that the author of the book claims that assurance does not necessarily mean absolute certainty or total control. What can you comment on that?
Well, if
And
if you
if my
want this,
example is right, I'm also interested in that.
well, uh, yes, your husband, if you like, in this example, can assure you that he's going to be home at 6 o'clock. Well, what he's saying there is he hopes and he believes that he will be there by 6 o'clock. That's a sense of the word assurance. But our job as testers is not to offer hopes or beliefs. Our job is to offer the facts, the truth, the actual status of the product. Now, what the term quality assurance holds for me is the idea that of a kind of responsibility that we make a certain kind of a guarantee or a promise. That's what assurance generally means. A statement that something will certainly be true or certainly happen. It's right there in that definition that's being quoted. Is it certain? Our job as testers is, this is going to sound bizarre, it's going to sound a little bit weird, but our job as testers is not to focus on quality. Everybody else is focusing on quality. What I'm focused on is threats to quality, lapses in quality. I'm focused on trouble as a tester. It's not my job to assure quality. The people who are building the product, the people who are making the product, they're the ones who are making that assurance, that promise. They're the ones who are saying, we'll be home by 5:30, maybe 6 o'clock. And not only that, we'll have a big bunch of flowers for you. Right? Well, they can make that claim. As testers, it's our job, it seems to me, to identify threats to the possibility that that will happen. To help identify risk.
Hope.
Yeah.
No hope from testers.
Well, I'm as hopeful as the next person. I believe that the current mess that the world is in, I'm hopeful that we will get out of it. But what is it? I think this comes from James, but hope is a wonderful feeling, but a lousy strategy.
Okay, thank you.
Moving on, Yosef. Yeah. So I wanted to talk about the book just a little bit. And we've noticed while you've been writing the book and during while you were working on the book together with James Buck, we saw several comments and discussions online where you've been disagreeing or
No, no, no.
debating with.
Where there were claims that you disagree between each other. So do you actually disagree between each other on anything, or you have a full consensus on most of the topics?
Well, here's what happens. James says something. I think it's wrong. I say so. We argue. We fight. Fighting is a little too strong a word, but we certainly have some fairly enthusiastic debates sometimes. And then he eventually realizes that I'm right. That's how it works.
Every
Who
single
eventually
time.
always right it's you, Michael.
Always, every
I
time,
see.
for sure. And then, meanwhile, I will present something to James, and James will be pointed in his critique of it. And I will go back to the drawing board, and I'll argue with him, and I'll argue with him some more. And then eventually I'll find out that he's right. But mostly, we align on pretty much everything. And then every now and again, this is funny when it came down to the testing and checking discussion. I made that distinction at a conference. I had an opportunity for a 2-minute lightning talk and got up in front of a bunch of people and declared that we had to think in terms of a difference between testing and checking. And then I wrote a blog post about it when I got home. And then after a week or so, I called up James and I said, "Hey, what do you think of my blog post?" He said, "Oh, Michael, why are you always going on about this? You're always so fussy about words, always so fussy about what we say." I remember I was on my bicycle when we were having this conversation. I was on a bike ride. And I remember exactly the moment at which I managed to sort of turn him to switch him to the thing where he agreed. I said, well, a check is like an assertion in a debug build, right? It's a check is something that is decidable mechanically. It's a single bit kind of true or false, yes or no sort of thing. All right. And he came around. It was only 2 hours of arguing about it that he came around. And then 4 years later, we found out that buried down deep, our agreement wasn't as deep as we thought it was. That we had a sort of shallow agreement as to what it was. So then we rewrote. In 2013, this one appeared on James's site rather than mine. Testing and checking refined. That article is where we dug up. I don't think it actually shows up in the article as such, but what we dug up was not simply that testing was a 1-bit kind of assertion, but it was a 1-bit assertion that can be made the subject of an algorithm. That's the key point. That it's a mechanistic process. So a check can, at least in theory, be performed by a machine that has been programmed to check for that particular condition or that particular outcome. And that's distinct from testing, because testing is a bigger process than that. A check is always embedded in a test, right? It's always inside a testing activity. Although, recently we realized it's not always inside a testing activity. Sometimes a check is just a signal that becomes inside a testing activity. Let me give you the example. The check engine light on my car, when that comes on, I'm not testing at the moment that check engine light comes on. But when I take it down to my mechanic, Jeffrey, and Jeffrey investigates it, then it becomes part of a testing process. It goes into a testing process. Sometimes a check can happen in that sense. An automated check can happen before one has deliberately decided to test. So anyway, that sometimes nuances of understanding and belief and so on get buried for a while, and we eventually sort it out. But here's another example. In that slide you were just showing, AI is a marketing term, AI is software, AI is automated irresponsibility. Those are not disagreements. Those things are consistent. They are all those things. And then AI is LLM. That's something that I think we would both disagree with, because, see, AI is the new word for something we've had for a long time: software. Right? Now, generally, people mean software that has been trained on a machine learning model, but that didn't stop people long before the popular GPTs came out. People were making claims of artificial intelligence in testing tools years ago, long before this. And you look around through the product, and there's an area machine model there, a machine learning model there, I mean. So AI is so poorly described that anybody can get away with saying AI now for practically any software that looks reasonably intelligent. But what I would remind people is that there is something sort of special about machine learning models, and that is they are bits of software. They're still software, but they're software for which we don't have the source code, and software that was not deliberately or intentionally designed by an intentional human. It's selected from a whole bunch of candidate algorithms, or selected by means of sort of tuning the algorithm as we go. But it's not done with deliberation and intent in the same way that regular good old-fashioned source code is written. And if we don't have the source code, we cannot understand how it works except by testing or by, in some cases, by disassembly. But that'd be kind of rough and tricky. But the way machine learning models work is that there's an element of GPTs anyway. The way GPTs work, there's an element of randomness built into them, stochastic stuff. So we can't test them deterministically. We have to test them statistically, probabilistically. So yes, it is true that many people conflate AI and LLMs, or more accurately, I think GPTs. But AI is a fairly empty, certainly very vague term.
Yeah, I would go, Yosef, to slide 10, maybe, to follow up with the questions around AI while Michael is still on the topic. Yeah, Michael, we just that's a very interesting thing. Thank you for mentioning your thoughts about AI. We've checked a couple of posts and conversations and blog posts that you've had around LLM and ChatGPT. And interestingly, one of the first posts appeared in around April 2023, followed by a series of articles later that year, where you and James began exploring its implications, risks, and limitations, and impacts on society and testing. And at that point, the industry was still in early phase of reacting to generative AI, as you said. It just appeared now, but AI exists in another form before. So it was early years, early phase for generative AI, and many of the ideas you raised at that point were quite provocative and ahead of mainstream discussions, mostly.
Thank
And
you.
now, yes,
Lots of
yes,
people are just coming around to this stuff 3 years on. It's very frustrating sometimes.
yes. It's very frustrating when people are not recognizing that. That's for sure. So, and now roughly it's around 2.5 years later. Both the technology and industry finally recognized something that you've been talking a couple of years ago. So since writing those early articles of yours around AI and everything, have your thinking since then changed around what is AI and what you wrote 2 years ago? Do you still think the same?
Yes. So your initial impression, often initial impression is always right. But over the last like several years, was there any substantial changes in your thinking about this technology? So not necessarily say, "Oh, I was wrong about something," but uh, was there anything in this area?
Well, I mean, I hope my thinking has changed over the last 3 years, because when the facts change, I change my mind, as John Maynard Keynes said. Um, there has been some, uh, you could say, improvement in the tools that are available, in the quality of some of what we're getting with agentic coding tools, for instance. I did in November 22, maybe early December 22, just after this stuff started coming out in ways that would affect programmers. A programmer and I sat down and we played with it for a few minutes, and it was dazzling. It was really pretty impressive, until we started to look a little bit more closely. And then we found that it was making systematic kinds of errors and mistakes. Well, over time, that has reduced a little bit. But the important thing for us, see, as testers, we're really all about the risk, aren't we? Shouldn't we be? So I am using agentic coding these days to write little tiny tools, tools that are not particularly complex. If I wrote them myself, it would take a little bit longer. They are not production quality. They should not be production quality. James and I have developed a vocabulary for levels of stuff that has been produced with the help of agentic coding tools. There's 4 levels to it. One is what we call slop. That's where we've had the tool generate something and we've run it and it doesn't crash. But we can't vouch for it in any way. Then we get to a stage after we've tested it some, whatever it is that's been generated. After we've tested it, we take it to a stage that we call plausible. Well, we've looked at it and we've covered it fairly shallowly. It appears to be able to do its job. It appears to be able to do something, and maybe there are nuances, maybe there are gaps, but it's looking plausible. That's the word we use. It's looking okay. When we've got more experience with it, with whatever has been generated by the agentic coding agent, or with the help of it anyway, we might call that provisional. Looks pretty good to the point where maybe even we're willing to share it with other people, but disclaiming responsibility for not having tested it completely thoroughly. Then there's a 4th level that we call validated. And validated means I know this product well enough that I'd be willing to stake some part of my reputation on it. I'd be willing to stand up for this thing because I've examined it, I've tested it, I've subjected it to some reasonably deep testing. Well, as it happens, those words very closely map on to the way we talk about coverage, where slop is you got to be a little bit careful here because when we're talking about both of these things, what we're talking about is our level of understanding of them, our level of confidence in them. Coverage isn't quite like that. Coverage is about the thoroughness of our testing, how thoroughly we've examined the product. But basically, if we're prepared to say that something is plausible, we've probably got level 2 coverage of it. Where level 0 is we know practically nothing about this thing at all. We know that it exists, but we don't know it. Level 1 coverage is, well, we've done some tire kicking, some very preliminary testing, but whatever testing that's been done, we don't really trust. We can't vouch for. It's interestingly, we can probably say with level 1 coverage, if they're terrible bugs, they may be obvious to us. But whatever testing we've done so far, we don't have a whole bunch of confidence that it would reveal serious problems. Level 2 coverage is, okay, we're getting to know this pretty well. We understand it reasonably. We've done some experiments. It may be in great shape. It may be in terrible shape. Coverage and quality are orthogonal categories. But we understand it fairly well, and we've maybe done the common, the core, the critical, the essential stuff. We've shown the essential operation of the product. There may still be deep bugs hidden there. Level 3 coverage for us is we have a really, really good grasp of this product, we believe. Any bug that you were to find right now that were serious would be considered a big surprise. Our clients, the developers, the managers, the public would agree with us. Whoa, that would have been a really, really hard bug to find in testing. So level 3 coverage is anything with any bug that escapes level 3 coverage for us represents the fact that there's something there to learn, rather than being evidence that we haven't worked hard enough. Those levels of coverage, by the way, are decided socially and qualitatively. They can't really be quantified. The numbers are just labels in that case. They're not. They're not scalars. They're on a nominative scale. So it matches to, in a sense, slop coverage, plausible coverage, provisional coverage, validated coverage. So that's how we talk about this stuff. So now the level of quality that we get from an agentic coding tool, the slop comes in at a higher level. It's better slop than it used to be, to some degree. But there's lots of variables that would make something that is slop or plausible look a lot better than it really is. And we're a lot of what I've been doing the last several days actually is looking at how that comes to be. And I've made some sort of interesting discoveries about Claude Code and the information that you can actually extract from the project logs. It's really pretty fascinating. There's some very rich JSONs associated with your project there. And some of that will explain a couple of things. One, the tendency of the model to forget stuff, and also the tendency of the model to burn tokens in ways that might surprise you.
I believe Joseph also has a view on burning
I
tokens.
have a question.
Yeah.
Say slope, but would it be fair to say that now at a sloppy level, almost anyone can quite quickly implement some exploratory or consistency testing idea? So like what you just mentioned, that there are JSON files with Claude Code interactions between between you and LLM, and you can have some idea what you would like to check there. Previously, it would take quite substantial time to implement this idea. And now you have some random idea that I would like to do this spot check, or I would like to have this consistency check. And then almost within a very short period of time, you have some sloppy implementation for this particular thing. So how it will change how people approach testing, and especially exploratory testing, when they have this ability. So previously they have to think before, they have to decide whether to allocate time for implementing some random exploration or tool supported exploration. Now, immediately you have a Spark and you have some sloppy script that is potentially capable to detect something. Will it change testing, and how it should change testing?
Well, I think so, a little bit. One thing it does do, and this has got to be acknowledged, is it removes certain kinds of friction from the typing part, and it does give people who are relatively inexperienced as coders the opportunity to get something done, right? And that's not to be sneezed at. For instance, I'll give you an example from my own experience. The other day, I was hassled by some copyright trolls. A company in Germany threatening they're going to bring legal action against me for this graphic that's on my website. Of course, it turns out that the people that they're acting as agents for don't actually own the copyright to this photo, and I have a license for it from a reputable distributor. Plus, I called the author or the person who took the photograph. LinkedIn makes that really wonderful sometimes. I was able to locate him and alert him to the fact that somebody was acting on his behalf and basically stealing or doing so fraudulently. So anyway, I thought, wouldn't it be great if I could rewrite that tool that I wrote years ago, and it took me, substantial couple of days to create this tool that would scan my website and collect a bunch of different information about it. So I did. I used agentic coding to do that. It took to get it to do exactly what I wanted. Took a few hours, a little back and forth with the agent and rendering it in a way that I like to see it. But the punchline is, of course, the images that are on my website. Because what I wanted to do was I wanted to be able to download the images and extract the metadata from them and see where, make a catalog of where my images came from and so on. Well, it turns out that when you upload an image to WordPress, it gets rendered into a different format. It goes from JPEG to WebP. And so my project, my 2.5 hour, 3 hour project, that, burns some tokens, only produced this result that I can't get the metadata that I wanted from the site. Oh, well. However, it's very seductive and very powerful. But one of the things we've got in our Claude MD files is please look and see if there is an existing tool that covers this before we go into writing a whole new thing that is less likely to be field. Well, it's not field tested by the time the GPT writes it. Maybe there's already tools or command line utilities or stuff built into the operating system that can do the job for us. Now, consider this. There's one thing we could do is we could write a program to scour a JSON for deeply embedded stuff and pull that out. We could do that. But there's an existing tool called JQ, which very few people seem to know about. It's like a super kind of grep on steroids for extracting information from JSONs, and it's really, really cool. But it's really gnarly. It's hard to learn. It's got this command line syntax that takes a while to learn. One of the things I do is I get the coding agent to help me construct JQ commands. And it's actually not too bad at that, pretty good at that. Sometimes it isn't, sometimes it is. But that's handy and that's cool. So that accelerates certain parts of this. On the other hand, when I do that, there are things that I give up. And what I give up is the struggle of trying to learn how to do something such that I learn something from the experience. And, it's one of those things where whatever change you make to any kind of system, like our system of work or our system of doing things, there are always trade-offs. So when James, this is work that James and I are trying to establish in terms of things like responsibility and consequences of using AI and so on. When you solve a problem or perform a task with software, with AI, with any tool really, you become separated from the details of some of those work processes. And that makes it more difficult for you to evaluate the result. If I'm not writing the code to a certain degree, it's a lot harder for me to evaluate it, to review it, especially considering the volume of stuff that these technologies afford. You get less practice in the skills and don't freshen the knowledge that enables you to evaluate the result. So I mean, there's benefits in doing stuff with AI, but we got to look at the consequences as well, right? It's not exactly a free lunch. You're less active, which reduces your alertness, increases susceptibility to distraction. That's actually quite true because very often I let the agent do something, go off, and do something else, and come back in a minute. When we trust the results, when we trust the output from the tools too much, especially when they appear to work, that results in something that we call cognitive surrender or a cognitive debt sometimes. If we're going to learn about this thing, it's going to take extra work relative to the amount of work it took to generate it. So we can accelerate the typing part, and we can accelerate the making of code part, but what we can't really accelerate to the same degree is our comprehension of those things. And it's sometimes you hear this metaphor. It's kind of like forklifts are great. Forklifts are really wonderful. They're able to lift very, very heavy things, but you don't take a forklift to the gym, right? If you are depending on tools to do certain kinds of work for you, your capacity to do that work yourself will atrophy to some degree. And that can have benefits. Pocket calculators, who's got objections to those? Well, I don't, unless my desire is to learn how to do certain forms of math quickly in my head. If I always depend on the calculator to do it, I will lose that cognitive ability, that exercise to do things. Because sometimes the speed of thought is faster even than the speed of a tool. Another example is people often use GPTs to try to create a test strategy ideas for them, which is okay. But the test strategy that gets spit out has never been reviewed or curated by anybody else. So the strategy ideas that are there may or may not apply to your product, but many, many pages of them for you to review. So I prefer to have those sorts of things in my head, rather, to start from there, rather than having the machine spit out huge amounts of stuff that's going to take me time to review. So you can get overwhelmed by that. That leads to cognitive surrender. And to some degree, when you code up something with agentic AI, sometimes you get the IKEA effect, where you're more invested in it because you made it, you built it. I mean, you didn't really build it. You just put the thing together in the box that came from IKEA. But at the same time, you lose the skills, or you never obtain the skills that would be required to build something more complicated. And that's one of the concerns that people have these days about junior programmers being replaced by AI. Well, how do you get a senior programmer? Well, it starts by a junior programmer getting experience with writing code and with making mistakes. We learn from mistakes. We don't learn very much from happy coincidental successes.
We would
Thank you,
like to
Michael.
check thank you, of course. We would like to check if there is a mistake in the book. 1 second. Oh, I stopped sharing.
Oh my goodness.
This one.
What's that?
Yes.
Yes.
So that's the chapter 2. So I've been amazed of the number of the part that you dedicated of the book, the part of the book that you dedicated to explanations of different terms and its classifications and various checklists and descriptions. One of the, and thank you for that, because I think it's very important to draw the baseline from where we are going to build the understanding. And one of the descriptions that you've had were around depth and breadth testing, among others. And we saw, so Joseph will comment on what we saw, but I will provide the example. So let's imagine when it comes to depth and breadth testing, let's imagine I have a website, a web page, and I am going to agentic IKEA to using any LLM, Claude or any other, to make to prompt a test script. So what I'm gonna do is ask to create a script that will go through the web pages, click different buttons and fields with a couple of permutations per each of these types of the fields, and check two things. One, to check console errors, and another one is just to try to detect HTTP failures with the page. That's all. So I'm going to cover everything that we have on the website in terms of the objects, and try to add there some input. And that's all. What would be where my test is going to be indicated in on the figure that you provided, the depth here on the corner, where we see the depth and breadth testing indication.
Well, it seems to me that it'd be tucked up in the upper left of that space. You are not looking for particularly deep bugs, in the sense that some of the bugs you're talking about are going to be reported in the console, right? So that's
Yes.
that's actually easily available to us by all kinds of means, and you don't need a GPT for that. You can certainly use a script to exercise the product, but what kinds of problems are you going to find? Well,
All
two.
functional problems, probably.
You will
Not.
not find all functional problems. You will not. You
Something
won't.
that is like no oracle. So if there is a crash, so what Anne-Marie is proposing is not just going through one, two permutations, but just go click at everything many times for a substantial period of time, but just use two simple oracles, whether something crashed or not, and whether we have JavaScript errors. So what we will have just two oracles. There are two simple oracles, so it looks like something very narrow. On the other hand, we go through, I'm not sure, thousands, tens of thousands permutations, and then somebody can say, okay, so it is deep testing. While
You
while
are you are providing the answer, Joseph. Wait.
Well, I agree, and I'm glad Yosef's doing that, because it means that he's in alignment with what we're saying, which is your coverage gets deeper the more variation you induce, even though it's not particularly broad, but the more variation you induce, the deeper it goes. Now, of course, when we compare that to what is possible in the world, it's still asymptotically close to zero, probably, because first of all, you're not, and this isn't a harsh judgment, it's just a fact. You're not covering every set of possible sequences. you're not covering every possible variation in timing. Certainly, because you're using a tool to exercise the site rather than exercising it at human speeds, there is a distortion of the experience. Now that there's benefits to that, lots of benefits to it. But if there's something associated with something happening over time that takes a while to manifest, if you click really quickly, you might be gone from that place before that problem manifests. I have this experience fairly often with the New York Times mobile app on my iPad. I'm reading an article, and I'm scanning through the article, and boom, all of a sudden, the article goes all white and the page tries to reload itself. Very frustrating. Happens again. I suspect it has something to do with updating the ads that are on the page. I don't know the cause of it. I haven't diagnosed it or debugged it. But this happens fairly consistently. But it takes a little while for that to happen. You got to sit on the page for a little while for that to happen. So as much variation as you might have in the various kinds of values that you put into sites, you don't have a kind of coverage that would involve sitting on the page for a longer time when you've got the machine clicking at crazy, insane rates. And again, look, there's nothing terribly wrong with trying to do that. It's just we got to acknowledge what is covered and what might not get covered. It's not possible for us to write code that will represent the experience of the user. It's possible for us to write code that will represent the behavior of the user, right? Represent it in some way, accelerating it in some ways, and losing focus on particular kinds of problems in others. That's okay. We've got to be okay with that, because there's no way, except with respect to extraordinarily trivial decisions, to show that software will always work in every case at all times. It's okay. We live with that. What we endeavor to do with testing is we try to shake things up, rattle things, change our perspectives and perceptions of things by intensifying one kind of focus and relaxing other kinds of focus. So the approach that you've got, where you've got some kind of agent that's clicking on buttons like crazy, that might reveal some problems. Cool, that's fine. And it's going to systematically miss other kinds of problems, and that's okay. We accept that, because as testers, we can't guarantee to find all the problems there are. It goes back to that assurance business, right? What we can promise is a good faith effort using the greatest diversity of approaches and tools and models and oracles that we can. And that's the best we can do. And that's okay.
So just to clarify, if I understand that right, so in the broadness, you're indicating that that's Oracle. What is checking the test and the system of the test? So in that case, we have two checks only. That's why we are on the left-hand side of the diagram, because we don't have the broads of the oracles. So just two checks indicated, and it will be with the greater depth, because we have many permutations, but we still will not have the broad testing in place at that time, right?
Yeah, here's another way you might think about it.
Okay.
Breadth is how many kinds of problems? Now, of course, you don't want to put that into a number, but what variety of problems can we discover? And depth is how deeply hidden might a given problem be, right? So the exercise where you're putting a lot of variation and looking for a particular kind of problem, a crash or a console error, that's one or two kinds of problems. But by inducing a whole bunch of variation, you increase the chance that you might stumble onto one of those problems, and that's a depth thing.
Yeah, I understood. Thank you very much. Joseph, do you want to comment on that, or it's clear and we're moving on?
No, I'm still thinking that some people might confuse the access oracles and coverage. So in Anna Marie's example, one can say that, but we performed breadth, breadth testing, broad testing. So we walked through all the pages, all the buttons. So it is not really narrow, etc. Or another example would be if we have non-deterministic system and we capture the output from non-deterministic system, so we captured some huge data set. And then we start applying different types of oracles against this data set in order to spot uh, the defects in this in application that produced this data set. And we have many different checks, many different oracles, but we are saying that when we apply these 1,000 different oracles, we are doing very shallow testing because we are going through x-axis and not y. So
Well, another thing that you should know about was it took roughly 5 years for James and me to come to an agreement on what we meant by depth or by breadth. James didn't want to recognize that at all. See, this is a case of James and I disagreeing. But at the time we had that conversation, it was just before the COVIDs. It was December 2019. We were wrestling with what did we mean by deep testing? And we'd been sort of trying to figure that out for a couple of years. Finally, we arrived on the idea that deep testing was testing that maximizes the chance of finding an elusive bug that matters. Every elusive bug that matters. So when we talk about deep testing, don't tell anybody. We're also talking about broad testing because a deep test is one that maximizes the chance of finding a particular bug. Deep testing is actually about the entire space of what you see under the two axes there. And that's a little bit not exactly sloppy on our part. We're aware of the problem. We just don't know how to resolve it very well. But depth of testing for us is about thoroughness. So it's when we talk about deep testing, we're also talking about breadth. Shh, don't tell anybody, at least to some degree. I'm not sure if there's a great word in English for something that encompasses both breadth and depth, and the thoroughness of how well we've covered a space that way. If anybody knows of one, you're welcome to let me know. But the word is really coverage. Deep testing is testing that obtains very good coverage.
Thank you, Michael. I think that we are ready to move with another thoughts that we had while we were preparing to this session. So, do I understand right that metrics is not something that you're reporting to your clients, and you're mostly tend to say that you tester need to report story for the client, and the story should be in a clear, in meaningful way to the client as the context driven testing approach that the RST is about. Is it correct?
Yeah, well, we're not opposed to metrics or measurement. That would be crazy. What we're opposed
Mm-hmm.
to is bogus measurement, bogus metrics. And one of the things I've harped about for a long time is that there are two senses of measurement, which I will label the Weinberg school of measurement and the Kahner school of measurement. There's very, very broad overlap. But Jerry Weinberg's notion of measurement was the art and science of making reliable and significant observations. So that is whatever your sort of a form of measurement. That's what he's talking about. Are you making a reliable and significant observation of something? The Kahner school of measurement is that measurement is the act of assigning numbers based on a model or theory to attributes of objects or events with the intention of describing them. So Kahner's notion of measurement, and it's in a wonderful paper by Kim Kahner and Pat Bond called Software Engineering Metrics. What do they measure and how do we know? That paper does a really, really good job at identifying a really important principle in that kind of measurement, which is something called construct validity. Essentially, construct validity is the process of assigning meaning to what it means for there to be one of something versus not one of that. Right? So that's really important when you're measuring things because you want them to be of a consistent, if you're counting things and it matters, you want them to be of a consistent dimensions, consistent significance, consistent meaning. So, okay, right behind me here, I got a bunch of books. I got a whole bunch of books. And somewhere in here, I've got something that is probably more like a pamphlet. Let's see if I can find one of them. The question though is, here's this. I just pulling this off at random. This is here a magazine. It's on my bookshelf. Does it count as a book? It's interesting because in the publishing industry, when people refer to magazines, I never knew this until I met a publisher, that they refer to the magazine as the book. Is it a book? Does it count as a book? Well, yeah, yes, all these little facts you find out after you've been living for a long time. Here is something. This right here looks like a book. And actually, if I open it up, it's a sorter of things. It's not a book at all. So, all right. That's not too hard to sort out when we're talking about physical things in the world. But so many of the things that we purport to be measuring in software engineering, are not physical things. they're more like constructs that we would see in the social sciences. What is a bug? What counts as a bug? Because a bug to you might not be a bug to me at all. I might, for us in RST at least, a bug is something that something about the product that threatens its value to some person who matters. Now, there's one way to make a bug disappear immediately, and that is to say, well, the person who's complaining about it doesn't matter. Right? We don't care about that person enough to fix this behavior. But I remember this is again a Jerry thing. Jerry telling me about this story where a guy at IBM got awarded an incredible sum of money because he had accomplished this amazing thing. He had produced a product that only had one bug logged against it. Only had one bug logged against it. Now, what was the product and what was the bug? The product was a compiler. I'd have to think a little bit to remember the kind of compiler it was. But it turns out IBM didn't have one. And Hitachi, another big computer maker back in the day, was eating IBM's lunch because they had an algol compiler. That's what it was. So Hitachi had one, IBM didn't. So they assigned this guy to write an algol compiler. And now IBM could say it had an algol compiler. Well, what was the bug? Bug was it didn't load. Didn't work at all. And yet, so you think, well, only one bug, it must be a great product. And then you find out it doesn't load at all. Oh, it must be a terrible product. But it turns out that by IBM's lights, it was actually just fine as a product because the IBM salesman would go in and they would go to the purchasing people and say, we've got an algol compiler. But then they would go to the salespeople would also go to the people who are going to use this particular computer system. And they'd say, do you actually need an algol compiler? And they would say, no, we don't need an algol compiler, but it's on this checklist that the procurement people have got. So they were able to satisfy that requirement. So here we've got this weird thing. Only one bug, it must be a great program. Oh no, the one bug is it never loads. It must be a terrible program. But the fact is, it exists, and its mere existence is sufficient for it to be a valuable thing, even though IBM knows don't sell it to people who need an algol compiler. Or, if you do, tell them they're going to have to wait for one that works. But meanwhile, it satisfies the requirement of IBM being able to put this check mark on it. So a bug is not something that we can count very well because it's just gone from 1 to 0 to 1 to 0 3 times in this story. Right? So let's not think of bugs as a valid unit of measurement. Let's not think of test cases or test scripts or even checks as valid units of measurement. But let's describe what we found. Let's talk about it. Let's report on it. And sometimes we can use numbers, certain kinds of measurements to illustrate certain things. A website can handle a certain number of hits at a certain rate, given that we're hitting the same thing in the same way. But maybe some of the pages on the site performance is terrible because a whole bunch of stuff has to get assembled from various server calls and local JavaScript and all that sort of stuff. And maybe on other pages, it's nothing. It just comes up real quick and it's static and all that. So even then, we've got to concern ourselves about measurements that are, as they say in the business, commensurate, where we're looking at things the same way and counting them the same way. And that actually doesn't happen very much when a bug is not a property of a product, but a relationship between the product and some person.
Thanks, Michael. We actually have a slide related to metrics that we wanted to raise with you. So you already provided the kind of metrics that you can consider helpful when it comes to the website. But still, if Joseph, if you're going to show the slides, because we are not seeing those. In the chapter 9, that was around test reporting without pretentious metrics, that is part of your new book. There is a schema indicating metrics and evidence where you're indicating that the intersection of metrics and evidence, there are some helpful metrics area. We are wondering what falls into those helpful metrics, on your opinion.
Here's one that might be helpful, and it is by design, by intention, a very rough way of evaluating something. We don't count test cases. A test case is not a unit of measurement. A test case could have thousands of steps and could include hundreds and thousands of checks. How big is that? That's not very helpful. But what we sometimes do is we'll talk about time, because time is absolutely a valid measure of something. And we will evaluate how thoroughly we've covered something by looking at the amount of time that people have spent looking at it. Now, that's going to be misleading if we don't also ask, well, what were you doing in that amount of time? So, what were you looking at? How were you looking at it? What we're trying to establish there, and you develop this after a while, is a kind of first order, maybe second order measurement for how thoroughly we've examined the product. So there's an example of something where we say, okay, we spent 16 test sessions on this new set of features in the product. That doesn't tell us very much, but it does tell us that we've spent more time than had we spent 4 sessions, and less than had we spent 40 sessions. Now, even then, what goes on during a session? Well, one of the things that when we're using session-based test management to describe and to orient and frame our testing, when we do that, we are careful to review the sessions such that at least a couple of people recognize the fact that agree that a certain degree of coverage was obtained, a certain amount of effort was applied, a certain amount of understanding of the product was developed in a way that is very roughly commensurate, very roughly. But that's something where we've got a number of sessions, and we've got some evidence. We've got an account of the testing work that was done in each one, where we've got an overlap between the time measurement and the evidential basis for saying, okay, these things are reasonably equivalent to one another in that sense. But the sort of vagueness of the amount of time and effort associated with this session is something that we try to uh, acknowledge and describe so that we don't let our clients get fooled by the numbers.
Yeah, so it's all context driven basically, and it's difficult probably to indicate what is helpful in general, right?
Yeah.
Anyway,
Yeah. Well, metrics or numbers that come without a story don't mean anything.
exactly.
Right?
Exactly. Going back to the story, I have a couple of questions, but before we continue, Joseph, if you have anything to comment so far.
No, I agree with it. So let's go into the story.
Yeah, I see that we're completely on the same page, and everything that you say about the metrics, it very much resonates with what we do. So it's really nice to hear the same ideas as we have in Exactpro. So about these stories that I tried to connect this previously, but we moved to another direction. We are going back to that. So once you're providing, you're saying that it's all connected and the testing should be provided as a result of testing should be provided in the form of story that is clear for the client. And here we have a couple of questions related to that. For example, if when a tester adapt technical findings into business language, um, there is there is naturally some abstractions and simplifications involved because it's impossible to tell everything how it is in a technical language in a business language. So how do we simplify reasonably in that case without accidentally omitting important truth about the system? And how do you suggest to balance clarify for stakeholders with competences and nuances of the processes that have been put together during testing?
Well, we talk about a three-part testing story.
Yes, that I'm referring to that as well.
Yeah. The what we're really telling the client about, what the client really wants to know about is risk to the business. Now, where does risk to the business come from? Among other things, it comes from product risk. The idea that there are problems in the product that might threaten its value. Now, discovered bugs that we found, represent business risk, right? Because they're maybe they matter to the business, maybe they don't. Maybe the business will suffer consequences because of these bugs, maybe it won't. But that is identified business risk. A bug that we found in the product is an identified business risk. Our clients want to know about that. That's the first thing they really want to know about. That's a manifest, if you like, that there's hey, this problem that we've seen that we believe could threaten the value of the product to people it matters. Business probably cares a lot about that. What the business might also want to be aware of, though, is there's some testing that we haven't been able to do, some testing that hasn't got done, some degree of coverage where we have not successfully identified a bug yet, but there is business risk associated with that lack of awareness of the product because we haven't tested it yet, or we might not even be able to test it at all unless things change. It is important for us to make our clients alert to the testing we've done, but also to the testing that we haven't done yet. Also to the to oracles that we're not aware of or that we haven't discovered. That is to say, there may be certain kinds of problems in here that we just don't know about because we don't have a means of recognizing them. Or the coverage that we've done might not have been sufficient, or that we've got might not have been sufficient to reveal those kinds of problems. Or there might be certain important ambiguities in what the clients and the developers and the customers seem to want, inconsistencies between those things. So it's our job to bring those things up as well. That is the most useful kind of simplification I can think of, which is we have identified this problem in the product. Now, sometimes they say, oh, really? How do you know? So that's when we talk about coverage, and that's when we talk about oracles. Sometimes they're not even going to ask about that. Instead of saying, well, how do you know there's a problem like that? A lot of the time they'll simply say, oh my God, and they'll go off to the developers and so on. Of course, we got to produce a report that would show evidence that the problem exists and maybe show some hints about where to find it or how to reproduce it. That's okay. But that is the most useful simplification I can think of, which is to say, somebody claims that the product is supposed to do this, it doesn't do this. Somebody says that the product does this, it doesn't. When we run the product today, we see behavior that's different from yesterday, and we don't have a good explanation for it. There's a potential for a problem here. Maybe it's because developers changed something and fixed something and didn't tell us why, and it's actually better than it used to be. But maybe it's not. So the inconsistency with history heuristic is one that we use in order to identify problems. Another heuristic we use is inconsistency with comparable products. Our product doesn't do this. That product does. Are you okay with that? So when we are trying to tell the story, very often just a fact will do the trick. And we don't need a whole lot of evidence when we've developed reasonably high trust. We probably need as I said, we probably need a means of allowing the client to see the problem for himself or herself. Certainly the developers would find that helpful rather than a vague rumor of a problem. But that's the simplification. Tell what the problem is, and tie it to business risk. And now,
but what if? I'm sorry for interrupting.
Go ahead.
An additional additional parameter for your speech. What if so you claim that testers are not responsible for the quality? We already discussed that, and testers are not doing actions for the quality, but they are doing actions for providing the valuable knowledge about the system and information about the system. What if management is trying to push the release out in production? They have that intention and they are trying to do it as soon as possible. And you as a tester is seeing problems, and but the I can't say metrics in this conversation, but the results that you have, they are they can be on the intersection. Like you can say that it's almost ready, or you can say there might be some severe problems that will prevent us to go further because of the risks that we have. So where is the line where you are providing this evidence? You need to provide them clearly, truthfully,
but at the same time, you see the risk that in case you formulate it for the client in a way that it will be understandable from their case that it's fine to go to production, they will do. So in that case, you should decide in what how to formulate the story for the client in order to impact on his decisions. So it means that in a way you are becoming an acting, not a passive tester. You're becoming um, an actor that impacts on the quality, eventual quality of the product, if I may say so. Is it clear?
Well, I have to say it's not really clear to me what you're asking. Let me.
I'm asking whether the tester should be in a position of abstracting itself from the making any kind of decision and just provide the story, or is there somewhere the situation where you are making some story on purpose of preventing your client from mistakes?
Well, my client runs the project. I'm not the boss of them.
Yes.
I don't manage the project. Now, if I'm a program manager, different story, right? If it's a different deal. But as a tester, it's not my job to seize the wheel and start driving the car. Right? As a tester, I don't do that. And no tester actually does that. And you see what happens when a tester tries to do that. The tester gets told by somebody in higher management, yes, in fact, we are going to ship. So shut up. Now, a manager who ignores the tester and the tester's lists of problems and says, I don't care about any of that, we're just going to ship, is, likely being reasonably foolish or dismissive. But at that point, I would ask, well, what's the point of me even providing work for you if you're not interested in any problem in the product, you're just going to ship? Well, that businesses don't work that way. Businesses don't work that way. If I say, well, although sometimes I'm thinking now, sometimes they do. For instance, Paul Holland, the very Paul Holland who was on a previous slide, is fond of telling this story. It's just before Christmas. A product that he's working on has two very broken features. It was back in the day when he was at Alcatel-Lucent, and this was a router that was supposed to be shipped to AT&T. And Paul said, well, we can't ship it in this state. And the manager said, yes, actually we can. And Paul says, these two features don't work. And the manager said, I know. And AT&T knows. But here's the deal. It's going to be a lot bigger a hassle because we're supposed to ship by December 31st. But our people at AT&T said, our people aren't even going to look at this until the end of January after everybody's recovered from the holidays and that. And at Alcatel-Lucent, the developers were quite confident that they could solve this set of problems by the end of January. And the product wasn't due to ship until the end of March. So management will do what management will do. As a tester, it's not my job to tell management you can't do this. It's not my job to be an obstacle, because I'm not really an obstacle. At most, I'm a sort of speed bump. I'm not, as a tester, I'm not in the position of running the project. So what can I do? I can give management a list. I give them a list. I say, here are the problems that I'm aware of in the product, and here are the ways that I can connect them to things that I believe might represent extra cost, loss, harm, damage, diminished value, reputational problems, bad feelings for your customers. Here's a list of things that I believe represent these kinds of possibilities. And then I'll ask, if they seem not to have heard me, I'll ask if they've heard me. But as soon as I know they've heard, it's time for me to shut up. Right? If they've heard my report, if they've accepted my report, and if I believe they understand it, then management will do what management will do. And that's fine. That's the way businesses run. Now, if
that's fair.
as a tester, if you disagree, you want to be a program manager, go ahead, be a program manager. Get promoted. And then your standards of quality will prevail until management decides that even if the product isn't as good as you want it to be, we're going to ship anyway because we got to make our quarterly numbers. And that, as a program manager, that happened to me too. And that's management's decision. The people who are running the company get to decide about the state of the product. As a tester, I get to tell them about the status of the product, and they decide to ship or not based on what I've told them, but also based on what other people are telling them and what their needs and desires are.
Yeah, absolutely agree. Thank you.
So two things that affected our thinking about testing substantially, we would like to get your brief perspective if you're familiar with them and if you have any view. So one of them is new software testing model by Paul Gerard. Do you see any similarities, any differences with RST? So do you have any view on his model?
I'm really encountering it for the first time. There are lots of models of testing out there. I'm looking at one of them, testing thought processes. Yeah, I wouldn't say creates models, but informs models. But that's a quibble. This is on the left. I'm looking at the leftmost diagram. Yeah, exploration of sources informs our models of the product, and testing uses those models. But testing also informs our models of the product, and so the loop there is. I would say reasonable. I'm looking at it at the first time, but the cool thing about a diagram like this is it prompts you to ponder it for a while, right? To look at it and try to wrap your mind around it, see what works. So the general loop of that we got there of refining our models in a cycle. That looks reasonably reasonable to me. And then on the right, okay, we've got the word informing showing up there. Models inform our testing, and testing informs our models too. So I'm looking at the right-hand side of things, the right hand of the middle of it with the red lines there around. I guess there's an open question in my mind as I'm examining this. I'm wondering adequate for what? Because adequacy is a relationship between somebody and something. So I don't know what the oh my goodness. I don't know what the specifics of that are, but this looks reasonable and conversation worthy to me for sure. Is it a new model?
Well, no, I think it was 2013, maybe 2016.
At that time, it was a new model for sure.
Okay.
Yeah, so probably
New model.
less, probably a decade ago, maybe more. But
yeah, well, I look at this and it invites further processing or discussion, but it looks at least reasonable to me. It's not the cool thing about it as it hits my eye is the cyclic nature of it. There's lots and lots of loops in there, and I think that's a worthy thing. Uh, uh, a lot of people want to see testing and software development, for that matter, as a linear kind of thing, but it's not. It's I've described it as a fractal. There are loops within loops within loops, and there are lots of little loops inside great big loops. And this diagram on the right seems to have a fair degree of that sensibility. So that's a positive, I'd say.
Thank
I
you.
think, on my opinion, it's very similar in this case in an explanatorial angle, very similar to what RST has
Yeah,
approach has. Is it?
yeah. It's as I say, our perspective is that testing is distinctly nonlinear, and this model reflects it reasonably well.
Thank you. So one more thing that also affected quite a lot, and for some reason, I thought for maybe a decade now that it should have been more popular. So it was published in like 20 years, more than 20 years ago, the concept of using a massive number of computer assisted checks or computer assisted generated scenarios, but for some reason this particular concept never, I would say, never became popular, and I always thought that it should have been more popular. Have you encountered it? Do you have any view on this one?
Well, that paper, uh, if I remember it correctly, suggests that it's a really good idea to take the software and pump a lot of stuff through it at high speed. I believe that a lot of what happened in that paper was informed by Kem's experience with the Telenova product. It was a phone switching system or answering machine system or something like that, a call handling system someplace. Um, uh, in that story, which I heard Cam tell several times, there's a kind of problem that would happen at extreme loads for the system, been broadly conceived, the notion of high load. Where there are a lot of calls on hold, things would get bumped and the system would lock up. Calls would get lost, something like that. In a way, that concept has not been embraced, but in other ways it has. There are lots of stories of people who have thousands and even tens of thousands, hundreds of thousands of automated checks running on their system, and they call that high volume test automation. I would, first of all, it would often be, in the cases that I was just describing, those would be high volumes of automated checks. What, as memory serves, what was going on in that paper was the idea that we would explore various forms of load and stress testing without necessarily having automated checks involved, just drive the system to process a lot of stuff. I think that's a really great idea for finding certain kinds of problems that would not be revealed in a direct interactive experience with the product. And I think back in those days, for at least some testers, that was a novel and interesting idea. In other domains, like in telecom, that sort of stuff had been going on for a long time. So uh, I think it was really good for this paper to come out, for it to exist. But a lot of the time, what we're seeing is people presenting stuff from other domains in really valuable ways to people who aren't used to seeing those things. And I think that was the real value of that kind of paper. Certainly very much informed by Kim's experience with the Telenova thing. Um, and it's basically another way to get, on one level, greater depth of coverage. But on another level, if you don't know what's going to happen when you perform a load test or a stress test like that, if you ramp up the stress on the system will eventually fall over. What you don't necessarily know from the outset is how it will fall over, or where it will fall over, or when it will fall over. And that, if I recall correctly, was the thrust of that article. And it's a really good idea. It's one of the kinds of testing that we suggest in circumstances where stressful circumstances, overwhelming the system, or undermining it somehow, depriving it of something it needs. That's a great idea, especially for certain kinds of systems that are going to be exposed to high volume, high load, high stress.
Yes, absolutely agree. Michael, it is such a pleasure to talk to you, and we've spent almost 2 hours on talking.
We
I
have.
know, I know that we agreed on one, but we couldn't stop listening to you and ask questions. I would suggest to wrap up, and I hope that everyone who've been hearing us, they are also had a very good time.
Oh,
Just
great.
to before we do that, Michael, do you have any last couple of words of to say to our audience of what we've already discussed? Anything?
Yeah, I guess I could wrap up by saying, hey, dear testers, it's our uh, job, it's our responsibility to do something that nobody else on the project is focused on. And that is to focus on trouble, to focus on problems, to focus on risk. Um, the rest of the project community is seized with the idea of envisioning success, and that's all to the good. That's a good thing. It's wonderful that they're doing that. It's our job, in a way somebody framed it a long time ago, to be professional pessimists. It's our job to focus on the trouble because nobody else in the project is focused on that. Now, that makes testing a socially challenging thing. One is, in two senses. One is we're challenging the product and people's beliefs about it in a social context. So it's socially challenging the product, challenging people's beliefs in a social context. It's socially challenging in that sense. It's also socially challenging because it's socially awkward sometimes. People don't want to think about trouble. They don't want to focus on trouble. Our reply to that is that, hey, we don't like trouble either. We don't like trouble any more than anybody. But uh, if there is trouble lurking in the product or in the system, in this socio-technological system that the product lives in, you probably want to know about it. It would probably be better for you to know about the trouble so that you can start to address it. Finding problems is the first step towards solving them. right? Recognizing that there's a problem there to be solved is the first step towards getting that problem addressed or fixed in some way. And if you decide as a business that problem isn't important enough for us to fix, or we can deal with the costs of that problem, that's fine. It's fine for the business to make that determination. But no one else on the project has trouble as their primary focus. Nobody else on the project has that as the first thing that they're thinking about. So that makes us socially challenging in this sense. It's socially awkward. We are different from other people in that sense. We're focused on the truth, and especially the truth about trouble, the truth about problems and risk. And that's how we serve our clients. We don't add value to the product, not directly, but we provide a valuable service to the people who are developing and managing the project. We add to the awareness of the product in that sense. So we're not adding value to the product itself. We're adding a greater perspective to what people think and believe and know about the product. And we do that through experiencing and exploring and experimenting. Demonstration isn't a great way to do that. Confirmation is not what testing is really all about. Testing is all about experimentation and experiencing the product and learning about it so that people can make sensible evaluations about it.
Thank you, Michael. Thank you. Joseph, do you have any last comment for
Well,
today?
only thank you. So it's like, once again, I was hoping to talk. So we probably exchanged lots of messages online, but we never, well, talked in person. So I
Indeed, it's nice
very
to meet
much,
you.
yes, very much appreciate. Thanks a lot for spending time with us and sharing your ideas. I do believe that your and James' contribution transformed software testing. Well, at least for us it transformed, but I do believe that for many other people it changed and it highlighted what it really means to think about software testing seriously and treat software testing seriously.
Well, thanks for that. We hope we've been helpful for sure. I mean, it's that's what we're trying to do. Why are these testers complaining all the time? And the answer is because we'd like to see a better world. We'd like to help our clients defend themselves against risk. So it's that fella. His name was Kalyana Rondo, I think, from many years ago. That said that the tester is a person who walks the tightrope between a professional pessimist and team player. And it's a nice way of putting it. We find problems now, so you don't get surprised by them later.
Exactly. Exactly. Thank you, Michael. Thank you, Joseph, for discussion. It was really fresh and insightful, cozy and safe, in a safe environment discussion. I hope that someone even call it eye-opening in case someone is listening and hearing Michael Bolton for the first time, which I doubt. And for everyone who is listening to us, thank you very much for staying with us for such a long time. And I wish you good luck and have a great day ahead. And just a reminder that other episodes of AI Testing Talks are also available on our YouTube channel, which will be the link available shortly in the chat. And we also have a software testing hub where we share software testing tips and related to AI, Gen AI, and overall software testing, which the link will be also available in the hub very shortly. Thank you very much for listening and have a great day. And we have a short clip in the end as a goodbye for everyone. Thank you.
Thank you to all of you too. It's been lots of fun.
Thank you.
Failed automation. Toxic software.
Is this the best a tester can get? Is it? It's been going on far too long. We can't hide from it.
Who needs testing?
We can't laugh it off.
Well, what I actually think she's trying to test.
Making the same old excuses.
Bugs will be bugs.
Bugs will be bugs.
Bugs will be bugs.
But something finally changed.
Allegations regarding gaps in test coverage and defects leaked into production.
And there will be no going back. Because we believe in the best in test.
Testers need to hold other testers accountable.
It's not a bug, sweetie.
Come on.
To say the right thing.
Not cool, bro. Not cool.
To act the right way. Some already are.
Hey guys, stop. That is not how we test software, okay?
But some is not enough.
Say I can test.
I can test. I can test. I can test. I can test. I can test. I can test. I can test.
Because the systems we test today will be the systems in live service tomorrow.